Okay. Hi everyone, I'm Maor. And this does not work well, just like it did before. So I'm a tech lead at Alooma, and we're going to talk today about how to handle large messages in Kafka. So this talk is not about Alooma, but it's important to give some background on how we use Kafka. So basically, we have a streaming pipeline. We develop a data pipeline as a service. And we have many hundreds of integrations, which we need to stream the data from all of them to whatever data warehouse our client have. So we built this thing on Kafka, and we're using it more and more and want to get the most out of it. Next, please. So what's the issue with handling large messages in Kafka? It's not a special limitation of Kafka, but most data queues has some kind of limitation on the size of the message. So you don't want to specifically force that limit down on your application. You have, if you try, you can increase the default limit, which is 1 megabyte, but it can cause issues. From what we investigated, it's that if you pass 10 megabytes, you will get probably performance degradation, and if you pass 100 megabytes, you will probably get a lot of issues, memory. Extreme cases can even get you out of memory on the brokers. Next, please. So why use Kafka for if it doesn't specifically match that case? Since we love Kafka, we want to use it for everything. It has a great group protocol, as you all know now. So, and we built pipelines. We don't want to reinvent the wheel for a small percentage of the data. Specifically, in Alooma, most of our data is, the events are small, but sometimes it can be large, even very large, hundreds of megabytes or more. Next. So, basically, you have two basic options for handling large messages. One is packeting. It's similar to what happens in the TCP protocol. So you take each message and you break it down to smaller chunks, and you transmit them all through the producer, and you read them on the other end. Sounds very simple. The other one is to use some kind of external storage and only hold the reference in Kafka for those large events. Next. So we're going to dig in a little deeper on the first protocol first. Using the packet model, it seems very simple on the surface. You have a message that is large, split it up, and transmit all the chunks through Kafka and read them on the other end. You even have the LinkedIn wrapper for the Kafka client, which already does this built-in. Your management complexity is much lower. You don't need to handle another database or data store to hold all those events. But there's some issues. The LinkedIn the client is the LinkedIn client is written in Java. As far as I know, LinkedIn for all other consumers and producers use proxy servers to write to Kafka. So if you have other runtimes, it can be an issue. And the complexity gets higher the larger your messages are. So, and the more producers you have. So if you suddenly try to write a 500 megabyte message, and you maybe have a few producers that write to the same partition, whatever consumes the data needs to hold those chunks in memory until it has all the data for all ongoing messages. So there's a little bit more edge cases to manage. There also might be some issues if you try to use something like a log compaction, since you don't have a single key anymore. You have many messages in Kafka that basically is still the same message. So, and also since it gets more complicated for large messages, we decided it's not a good fit for us. Next. So the external store is a lot more flexible, but it's also because it has a lot more options. You can basically use anything to store whatever you the actual data. You can use it to decide whatever threshold you want and then keep only that data there. Management complexity is obviously higher, since instead of only Kafka, you have Kafka and something else now. But whatever, usually the complexity of the code will be lower, since most stores has SDKs for many different runtimes, and you can write compatible code for that. So, for example, we use consumers and producers in Python, Java, and Node, so we wanted to support all of those. Next. So this is only some examples for data stores which has very different use cases, and each of them will probably match a different case of trying to implement this this way of managing large messages. We're going to focus on two of them today, Redis and S3. They seem like two stores you usually don't think about in the same sentence, but we're going to get in a little deeper and see how they can help you. Okay, so Redis, I mean, probably you all know it. It's extremely fast. You can get to sub-milli latency. It's completely in memory usually, unless you use maybe Redis Enterprise over SSD. It can be very good for some cases, but it has issues with stuff like consistency, and once you want to make it more persistent and more consistent, your management of it will be probably harder, or you can use some kind of managed solution like a Redis Enterprise, but that makes it even more expensive than managing on your own. Amazon S3 is really the other side of the curve for those kind of things. The scale is virtually unlimited. Instead of storing everything on memory, you store it in files in the magic of Amazon's cloud. It's really cheap. I think like 2 cents per gigabyte or something per month. It's usually very easy to write and read from S3 from basically every environment you can think about. It's managed, so the entire point of increased complexity usually goes down. It's more specific to Amazon cloud, but probably you will have something similar in every other cloud you will use, like we showed before, Azure Blob Storage or Google, I don't remember what's the name of the Google one, but it has the, for if you want to, when you have a lot of files, a large file, it's very large, but you don't have a lot of those, S3 can be a very good solution. Next. So let's go over a little bit of the Alooma use case. Probably have a lot of use cases that will be similar to it. So most of our data is under 1 megabyte, usually much lower than 1 megabyte, anything from 1 to 100 kilobyte, terabytes of data and billion of events per day, which we need to handle. We have consumers and producers in multiple programming languages. And what was most important to us is data, and to our customers is the data integrity. So it was very important to us. Implementing this solution won't hurt exactly once, and persistency and the consistency of our data. Next. So what we decided to do is write a wrapper which is pluggable. The first one for S3, since we really think it covers our use case extremely well. But we also thought since we looked about it a lot, that a lot of companies can also use this and more. So we will release it as open source. It's still under construction. The open source, starting with Java and then the Python client. The point is of having it as a relatively small wrapper, so you can use whatever consumer and producer you like, not implement the whole consumer producer from scratch. So you can use it with Kafka streams or with even Kafka Connect application, or just regular consumers and producers. And that's it. Next, please. So really, using S3 as a backend for Kafka really lets us support all of the high throughput. Since it's on AWS and the amount of very large messages is small, it will let us. It will be a low impact on our throughput, but it will still lower cost a lot, since those large messages can be very large, and hundreds of megabytes per message can be a lot of data in the long term. Data integrity is basically built in for S3. We do have the issue, S3 is eventually consistent, which means after you write something, it's not immediately there. It eventually will be there. So you do have to handle waiting for the data if it's not there already, and waiting for it better. But it's relatively easy to build the multiple implementations to match, and also have it pluggable with other backends. So in case you want to replace S3 and use something else, you can. Next. Our grand vision for the future is to use some kind of hybrid solution. So I really think it will let both Redis and S3 shine. Also, it doesn't have to be those specific use cases. It can be anything similar. But using something like Redis as a cache and not as a persistent storage, and using S3 as a backup to hold the data long term. So when you write the data, you write it to both Redis and S3. And when you read it, you try to read it from Redis. And if it's not there, you get it from S3. That will give you a relatively low cost and simpler management of the Redis cluster, but still let your real-time streaming application be much faster and not rely on something like S3 to load its data. And we think it's really can be a good solution for a lot of companies using Kafka and using arbitrary data in Kafka. Last one. Thank you, everyone. And by the way, we are hiring, so I mean, any questions?